Hi, I'm Josh Cable in the Counterman Education Center. In the past, the only vehicles that featured air suspension systems were luxury sedans. But more and more OEMs today are using air suspension to provide a luxury feel for SUVs and pickups. These systems not only offer luxurious ride quality, but some also are capable of adjusting ground clearance, and they can increase stability for towing and hauling. A conventional coil or leaf spring suspension relies on rubber bushings to help isolate road shock and vibration. An air suspension system uses hydraulic shocks and struts to dampen the oscillations of these metal springs, effectively isolating the driver from the road on a cushion of air. At its most basic, an air ride system consists of air bladders, a distribution system of air lines and valving, and a central compressor. Modern air ride systems also include an electronic control module, ride height and duty cycle sensors, and a driver interface consisting of switches and indicators. These are considerably more sophisticated than the old school air shocks that parts specialists used to sell, and the cost of replacing these components reflect the advanced technology involved. So what can go wrong with these systems? Well, air springs and struts can last up to 100,000 miles, but the computer and height sensors usually last the life of the vehicle. However, one of the most vulnerable and expensive components are the air bladders. Like a metal spring, these rubber bladders flex continuously while in operation. Fatigue from constant flex cycles, coupled with natural degradation over time, can lead to leakage of the bladder. Abrasion from trapped dirt, gravel, and corrosion also can compromise the integrity of these air cells. Once air begins to leak from the air strut or spring unit, the vehicle settles until the compressor kicks in, attempting to restore ride height by increasing the air pressure of the system back to specified levels. Constant cycling to maintain pressure and ride height can lead to overheating and eventual failure of the compressor. Modern systems have a monitoring function built into the control module, which can turn off the compressor when it senses an overheating condition, a fault in ride height sensing, or other electrical failure. It also will set a fault code in the air ride module and disable the system until it can be serviced. The harsh underbody environments in which these compressors live also can contribute to electrical failure. Once the compressor stops working, the signature sag affects not only ride quality, but also the vehicle's stability and handling. In our next video, we'll talk about some replacement options for air suspension components. I'm Josh Cable. Thanks for watching.